Okay, on this problem, it says a bird is attempting to fly south at 13 miles an hour, and wind is blowing from the northeast at 3 miles an hour. What is the resulting speed and direction of the bird? So these are basically two vectors that are going on in this problem. Two vectors. And so the first one is the bird. So let's just do the bird vector. So whenever we have a vector, we go whatever the magnitude is, cosine theta, and magnitude sine theta. But vector, let me mention vector angles theta must start at 0 degrees, meaning be the actual angle. So what am I talking about? Well, for the bird, let me draw the bird here. It says the bird is flying south at 13 miles an hour. So that bird, that crazy bird is flying south. Remember the north, south, east, west. So that bird is flying straight south. So there's two ways you could do this. You could say, and it's flying 13 miles an hour, 13 miles an hour straight south. You could say, look, it's just going down 13 and over 0. That's the bird vector. It's going to the right 0 and down 13, right? This vector goes right 0 and down 13. Or you could do the formalities of putting in the m13 cosine. Now, what angle is that? Well, that angle from 0, remember you got to start at 0. This is 90 degrees. This is 180. This is 270, huh? Cosine 270, and this will be 13 sine 270. Hit the buttons on your calculator, you'll get 0 and negative 13. So either way, I think it's easier. You know, whenever vectors are straight up or straight down or straight right or straight left, they're right on an axis line. You don't need to do the formulas. You can just tell that's just down 13. So negative 13 over 0. Over 0, down 13. So there's the bird vector. So we're just going to get the two vectors and add them together. That's how, you know, physics people, engineering people, science people do vector. That's how they do, like if you have two forces acting on something. You have the bird trying, he's flapping his wings and pushing himself straight south, but the wind is blowing from the northeast. So let's do the wind vector now. So now for the wind vector, so I'm going to draw a little axis system again. Now here's again north, south, east, and west. The wind is blowing where? From the northeast. So it's from up here, meaning it's blowing straight that way, isn't it? It's from the northeast. So it's not to the northeast. Notice it's from the northeast. So it's going, you know, if I say the wind is coming, you know, from the northeast, then it's going to the southwest, right? This is the northeast up here, going to the southwest. So, okay, so what angle is that? Well, you could look on the unit circle. You know, again, this is 0, 90, 180, 270. So it's right between 180 and 270. It's 225. You could look on a unit circle. You'd see it's 225 degrees. So therefore, the bird or the wind vector is going to be, and how fast is the wind blowing? Oh, 3 miles an hour. It's going to be 3 cosine 225, 3 sine 225. Just like that. So let's hit the buttons on our calculator. I know what that is. I'm getting negative 2.12132. Use about 5 decimals is safe. And this is same thing. And that makes sense, doesn't it? This bird is flying down and left, negative and negative, down and left at the same amount. So there's, I mean, that's the wind. Sorry, that's the wind, not the bird. That's the wind vector. That's how the wind is blowing from the northeast, blowing that way. And then here's the bird vector, okay? And so then the question is, what is the resulting speed and direction of the bird? So let's figure that out. So the result is going to add those two vectors up. We're going to take the 0 minus 13 bird vector. Now the bird is trying to make himself fly. And we're going to add to that the wind vector, which we now know is negative 2.12132, comma, negative 2.12132. Let me just get rid of this right here. And add those up, and we'll get the result. The result of the bird trying to fly and the wind blowing on him. So you're going to add this and this. That's pretty easy math. Negative 2.12132, comma. And then this and this. Hit the buttons on your calculator. You can just tell 13 and 2 is 15. The decimals just sit there. So there's the result of what happens between the wind and the bird. And so now what are they asking? Now they're asking about the bird, his miles per hour. Now, what's that? That's the magnitude. Do you realize that's the magnitude, the speed of the bird? So the magnitude of a vector is the square root of x squared plus y squared. So that's going to be the square root, and this will be 2.12132 squared plus negative 15.12132 squared. Let's hit the buttons on our calculator. Let's see, squared plus 2 equals, and then square root. What did I just do? Oh, I messed up. We're going to trade 2.12132 plus 10.122 equals, there we go. Okay, I'm getting 15.26939. Let me get check. Is that the right answer? Yep, there it is. I get that answer key right there. So we got that right. So that's the speed of the bird. And now the last thing they're asking is, what is the direction of the bird? What's the direction? So I can take this resultant vector here, and let's figure that out. So I've got the resultant vector. Let me write it down here. Result vector. This is the result of the bird trying to fly and the wind blowing him. Okay, and so let's think about what that is. So that, look at that vector for a minute. It's going left and down, isn't it? Negative, negative. So it's going sort of like this way. It's going left 2.12132 and down 15.12132, like that. And so here's the result. It's left and down. So, okay, so they're asking what the direction is there. What the direction. Remember from the notes? Let me show you the notes, how you find the angle of, there's the magnitude and there's the angle of a vector. Go back, I'll paste that in here so you can see that. Let's do it here. Okay, and so how do you find the angle of a vector? You draw the vector. We did that. Find the vector in inverse theta is the inverse tangent where that's absolute value y and x. So I'm going to go, okay, so that angle, so we need to find this angle right here all the way to that vector, that angle. What is that angle? Or actually, let me just back up. We don't have to do anything that far. We just want to find this angle right here, huh? Let's just find that angle right here. Well, this is a right triangle. Tangent, this is the opposite side. This is the adjacent side. Like that. So you can just say tangent of that angle theta is opposite negative 15.12132 over negative 2.12132. Like that. Is that making, well, I'm probably confusing you. Let me back up. Let me just follow the notes. That'd probably be easier for you. I'd probably being too casual. Let's just follow the notes. What do the notes say? To find the angle theta, it's tan inverse of, this is y, this is x, absolute value y. So you take the positive 15.12132 over positive 2.12132. Hit the buttons on your calculator. I'm going to do that right now. Make sure you're in degree. We're trying to get a degree angle, so make sure you're in degree mode. And I'm getting 82.01427 degrees. But careful, let's look at the notes again. So look, it says to find the angle of a vector, draw the vector, find the vector, tangent inverse of, this is absolute value y over absolute value x. We did that. But currently we only have the reference angle. To find the actual angle based on the quadrant, you got to find your quadrant and use the formula. Oh, okay. What quadrant we're in? We're in quadrant 1, 2, 3, 4. So we're in quadrant 3. So quadrant 3, what does it say? Third quadrant, 180 plus the reference angle. It's 180 plus the 82.01427 degrees. And then that comes out to be 262.01427 degrees. So that's the actual angle. And that makes sense. It's almost 270, isn't it? Because it down here would be, this is 270, as you know. So 262, that's almost to there. That looks right. Looks like that represents right. Now, careful. How are they asking us the question, though? Math question. They're saying the bird is flying whatever degrees, north or south of whatever. So how are we going to say that then? Well, let's go look at our options real quick. If I click on this, the options are south or north. And then the second one, it's east or west. Okay, so I got to start with south or north. Okay, so if I want to give it like they're asking for it, then I'm going to start with straight south and then find out how far it is this way. So I'm going to say the angle, the bearing angle, is south, but how far to the west? Well, if this is 262.01427 degrees, and this, as you know, is 270 right here, then 270 take away the 260.01427 degrees is 7.98573 degrees. So it's south that many degrees to the west. See how I came up with that? This angle is south, but it's a little bit of degrees towards the west. Remember the directions: north, south, east, and west. So this angle, which we found the actual angle is 262 degrees, 262 degrees to there, that's from 0. That's how far from 270. Subtract from 270, it's 7.98 degrees. So it's south, but 7.98 degrees to the west. That's the resultant angle. I know that's kind of tricky, isn't it? So one more time on that. When you get the resultant vector, I used the notes, which are right here, and they told me to take inverse tangent, absolute y over x, and then do the quadrant thing. So I did that. I did inverse tangent of that, got this angle, but then I was quadrant 3, so it's 180 plus, so 262. And then 262 is almost to 270. So I subtracted from 270 to get that. So then it's south, but a little bit to the west, 7.98 to the west. South 7.98 to the west. Make sure that's right. South 7.98 to the west. Exactly. So that's how we find the bearing angle. So there we go.